All right, we have section 1.3, which is on algebraic expressions. Specifically, we're going to evaluate and simplify algebraic expressions. It's stuff you've done in the past before here, so most of this will just be a reminder for you. We'll start off with some verbiage here and writing of expressions, and then we'll continue on with order of operations, and finally with combining like terms. So here we have example 1. This is write an algebraic expression that models the word phrase 5 times the quantity 3 less than a number. This one's a little bit tricky because it's got the word quantity in it, and it also has less than in it. Those are things that are a little bit tricky. The 5 times, hopefully you're thinking, oh, that's no big deal. We'll just do 5, and I put a dot here. We're big boys and girls now, so instead of an X, we'll use a dot for times. Something we want to make note of is when we see quantity, we're going to use parentheses. So if you look down here where it says keys, use parentheses when you see quantity is one of those times where you should be using parentheses. So whatever comes after the word quantity is going to go in the parentheses. Now, it says 3 less than a number. Well, a lot of people, I like to set you loose, would put 3 minus x or 3 minus n or whatever your favorite letter is, but that would be wrong. If you think about what your age is, let's say you're 15, and I say, what's 3 less than that? I would guess most of you would say 12. So to get that 12, you wouldn't go 3 minus 15, you'd actually go 15 minus 3. So when you see 3 less than, you actually have to reverse the order. You're going to subtract the 3 from something. What are you going to subtract it from? Whatever your favorite letter is. You could use X or N, and there you have your answer. So when you see quantity, parentheses. A couple other times when you want to use parentheses is when you see the word sum, or I'd probably put these in reverse order, but I'm going to go with it. Difference. I say that because I have this little stubby line at the end here, and I have a big line for sum. I should have put difference before sum, but you get what I'm after there. So quantity, sum, difference. Put parentheses, and whatever follows those 3 words, put that inside the parentheses. Example 2. Write an algebraic expression that models the following situation. You were allotted 1,000 texts this month, which this is old school. You used to have to pay per text. I would assume most of you have unlimited texting now. That's progress, huh? Anyway, so you got 1,000 texts, and you use 30 per day. How many texts have you left after 12 days? Well, let's write the expression first. Let's not try to answer the question. So you have 1,000 texts, you use 30 per day. So I'm starting with 1,000. And what does it mean to use something? If I use something, it's gone. How do you make it gone? You subtract it. So I'm going to subtract 30. Well, I don't just subtract 30. I have to subtract 30 every day. That per is kind of a key word. When you see per or for each, something to that effect, that's a good time to be thinking, you know what? I'm going to need a letter there. So maybe I'll use a D in this case. That stands for every day. Every day I lose 30. So if it was 1 day, I'd go 30 times 1. 2 days, 30 times 2, and I'd take away 60. 3 days, 30 times 3 would be 90. I'd take away 90. Okay, so this is an algebraic expression. And then how many texts would be left after 12 days? Let's plug that in. 1,000 minus 30 times 12. 1,000. You multiply before you subtract. 3 times 12 is 36. Add a 0. 1,000 minus 360 is 640. So you'd have 640 that would be left for the remaining, depends how long the month is, 28 days, 29 days, maybe February a little less. So how many texts would be left? 640. Let's put a word there so we know what we're talking about. Texts. Okay? You get 6 hours of sleep every night, plus an extra 7 minutes every time you hit the snooze button. Write an expression that represents the amount of sleep you get nightly based on the number of times you hit the snooze button. Well, here you got to be careful, because your 6 is in hours and your 7 is in minutes. Those are different, so I need to make them so they're alike. Now, you could change the minutes to hours. That would be a little bit trickier, I think, than changing the hours to minutes. So I think for most of you, changing 6 hours to its equivalent of minutes, there's 60 minutes in an hour, so 6 times 60, 360 minutes. So on a given night, you get 360 minutes of sleep. That's what you start with, plus every time you decide to hit the snooze button, you get 7 more. So you can get 7 if you hit the snooze button once, you get 14 if you hit it twice, 21 3 times. This area over here, the 7 is what could change. It might not be 7, it might be 14, it might be 21. So this is where you need to have your letter. I'll put a capital B for button, snooze button. So every time I hit the snooze button, I get an extra 7 minutes. It's like 7 per times, 7 per each time I hit the snooze button. There's that per, I tied the per in, like I was talking about in the previous problem. So we wrote an expression, and I have a follow-up question or anything. Right expression represents the amount of sleep you get nightly based on the number of times you hit the snooze button. That looks like it's it. That is the answer. That's all I'm looking for. So B, you might want to write that down, where B equals times hitting the button. And again, these boxes over on the left, in case you forgot, 1 through 4 over there. 1 if you have no clue what I'm talking about. 4 if you can teach it to a friend. 2, you kind of got it, but you're not real confident. 3, you're pretty darn confident, but maybe you can make a simple mistake. Next page. Evaluate the expression. Remember to use the order of operations. Put parentheses around every number that is plugged in for a variable. Now maybe you forgot your order of operations, so I guess this is a time for me to jot it down here. You might have been taught, please excuse my dear Aunt Sally. Problem with that is I get students who think multiply is more important than divide, and it's not. But it's please, parentheses, P, excuse, exponents. And then my dear actually goes together because you have multiply, divide, and it's a left to right situation here. So whatever is to the left goes first. So sometimes it's multiplication, sometimes it's division, and the same thing with add and subtract. Aunt Sally. That's also left to right. For both of those, multiply, divide, and add, subtract. So try to keep that in mind. So what do I have up here? I've got 10 minus 3, and then there's nothing between the 3 and the x, so what does that mean? That means multiply. So I'd have 10 minus 3. Whenever you plug something in for x, please use parentheses. And make sure that whatever is next to the x stays outside the parentheses. So here the 3's next to the x, that's outside my parentheses, but so is the square. The square is outside the x, so that goes outside the parentheses. Now you do the order of operations. There's nothing to do in the parentheses. I wrote parentheses, but the only thing in there is -2, and there's nothing to do. So I'm going to go to exponents. I'm going to do -2 squared. -2 squared means -2 times -2, which is actually a positive 4. And then I have minus and multiply, subtract and multiply. Multiply comes first, so I need to do the 3 times 4 first. And the last thing I do is to subtract. So the correct answer to this is actually -2. Now, what will happen is some of you will just do this in your calculator. You'll put 10 minus 3 times -2 squared. You won't use the parentheses, and what your calculator is going to do in that case is it's going to do the 2 squared. It's going to say that negative stays on the outside. You didn't put in parentheses. So what -2 squared means in this situation without parentheses is the opposite of 2 squared. So your calculator would do the opposite of 2 squared, which is -4. You do 2 squared is 4, then put a negative on the outside. Then your calculator would do the multiply, and really what you're multiplying is a -3 by a -4. So that would turn into a positive 12. And your calculator would give you an answer of 22 if you went ahead and did not put the parentheses, and that is the incorrect answer. You should get -2, what we had at the beginning. So you need to be real careful when you plug a number in. Always use parentheses, plug in for the parentheses. So I'd have you go ahead and try this one on your own. Be checking around the class to see how that went. I guess I'll go through it real quickly here, not showing you every step. Let's see, we have 4 plus 2, -5 minus -3. And again, you could put parentheses around that. Minus -5 plus -3 squared. So that's what you should be looking at doing right there. Looks like I missed a parenthesis right here. Okay, so I'm going to do a little math in my head here and see if I can get it right. Double check, make sure I get it right here. Looks like 0, that looks like 5. Looks like the correct answer should be 14. So make sure you get an answer of 14 there. And if you don't get an answer of 14, you keep trying it and you don't get an answer of 14, come back and say, Mr. Mitchell, you screwed that video up, you need to go back and fix it, or maybe I might make a mistake too. So I'm pretty confident in that answer based on what I wrote there. So should be 14. Okay, turn the page. And we'll do a little combining like terms. Typically, I find my students pretty good at combining like terms. Combining like terms, to combine like terms, you need to have variables that are exactly the same with the exact same exponent. You put those together. This problem, what would I do first? I would look inside the parentheses and see a 3x minus x squared. Go, they're not like terms, I can't put them together. So I would get rid of the parentheses and I would distribute. Now here's the kicker. This is a -2, people. You need to use that minus sign in front. So this is -2 times positive 3x. That's -6x. And then you have -2 times -x squared. That's positive 2x squared. Parentheses are now gone. Very common for students to make a mistake right here. Get the wrong sign because they don't do negative times a negative, get a positive. Now we have the like terms. 3x squared goes with 2x squared. That gets you 5x squared. You don't change the exponents. It's like if you have 3 of something and I have 2 of something, together we have 5 of that something. 3x squared, so it's having 3 of some number. 2x squared, so it's having 2 of some number. You put them together, you get 5 of that number. And then we'll go ahead and put the -4x and the -6x to get -10x. So there's our answer, 5x squared minus 10x. Example 7, no parentheses to worry about, so I'm just looking for like terms. I'm looking at the 5x to the third y, and I'm looking over here at 10x y to the third. I'm like, oh, maybe I should put those together. I go, wait a minute, no, someone's trying to trick me because x to the third is not the same as x. This doesn't have an exponent, so these are not like terms, so they do not go together. So 5x to the third y is part of my answer. And nothing goes with the 10xy to the third. That is part of my answer. Well, what can I put together? These two things. -xy and -6xy. They go together. This is like -1xy. So -6, -1. -6, -1 is -7. And you leave the letters the same. -7xy. There are the terms combined on that problem right there. And I do believe another one down there. Oh, almost forgot fraction one. Last one here. The rest you're reviewing on your own. Last one, fraction one. In order to add fractions, you need to have a common denominator. So a common denominator of 2, 4, and 8. What do 2, 4, and 8 all go into? They all go into 8. So I'm going to change them so they're all over 8. Well, the last one's already over 8. the last one's kind of silly. It was actually 2 over 8. I could reduce that to 1 over 4 and made a common denominator of 4, but oh well, didn't see that right away, so we're going with 8. 2, 4, and 8, all going 8. So I got 5x over 2, and I want to make that over 8. How do I get 2 to turn into 8? I multiply it by 4. 4 times 2 is 8. And then I take the top times 4. You guys remember that? If I multiply top and bottom by the same thing, it's like multiplying by 1. So it doesn't really change it. If I multiply by 1, the number stays the same. It just looks different. 4 times 5x is 20x. And then how about the middle one there? I need to go from 4 to 8, so I'm going to take that. Sorry, I wish this was a little bit bigger here. I'm going to take this times 2 times 2. So this is 2x. And I guess in the spirit of order of operations, I will work my way left to right here, because technically I should do adding before subtracting here. It won't matter because I could turn this to a plus negative at the end. I could make that a plus negative. So I could put the back 2 together and just say, oh, they cancel. But I won't. I'll say, all right, let's put these front 2 together. It'll be 22x over 8 plus negative 2x over 8, or minus 2x over 8, which is 20x over 8. When you add, subtract fractions, you do not change the denominator. Just add or subtract the numerators. This one would not be done because 4 goes in the top and bottom. So you divide them both by 4, and you get 5x over 2. There's the lesson 1.3. Thanks for watching.